Let's get started with a demonstration of Symphonica. Before we get into any actual executions, let's quickly cover the major domains of Symphonica and their high-level purposes. As seen in the left side menu, Symphonica has a number of main sections. The first few domains to consider are the service domain, workflow domain, and resource domain. It is important to understand their main purposes and how to use them to build the no-code configurations required for Symphonica to deliver on various use cases and business objectives. The service domain is used to define and build the service specifications within the user interface. By modeling these service specifications, Symphonica is building a knowledge base of the business and of the network. This knowledge base will be required to accept a service order and translate that order into customer-facing services, resource-facing services, and ultimately the resource configuration commands required to deliver and orchestrate those services. As part of the no-code strategy, Symfonica's user interfaces uses template format to enable the modeling and configuration of the service specifications. This includes the assigning of the service code, maintaining of the version control over the specification, and defining the associated characteristics, service relationship, and supporting actions of each service specification. Similar to the service domain, the resource domain is used to model the resource specifications. This modeling further expands the knowledge base of Symphonica to include the network resource definitions. The types of resource specifications supported by Symphonica are NMS, device, and other. An NMS is a resource with which Symphonica will typically maintain a connection and a connection status. A device is usually an endpoint for a service such as an ONT, universal CPE, or a port. Symphonica may or may not run commands directly on a device. As such, it does not expect to maintain a connection as it does with a resource of type NMS. The type other, as one might expect, is to model resources that do not meet the criteria for either the NMS or device types. Some examples are IP pools, authentication groups, and VLAN pools. Another key feature under the resource domain is the inventory itself. Here, Symfonica's user interface will display the individual devices with their lifecycle status and customer association. The NMS inventory shows the lifecycle status and also the connectivity status. The workflow domain contains the process manager and the workflow order specifications. This is where the workflows related to the service or resource management are built and controlled. Workflow order specifications are another part of the no-code building blocks that contribute to a highly functional service and resource management capabilities of Symphonica. Each workflow order will have a unique name or code as seen in the user interface. This name will be linked to a specific BPM process. Each workflow order specification will also allow the designation of inputs and outputs related to the objective of that particular specification. Symfonica's order manager gives visibility into service orders, workflow orders, and resource orders that have or are currently being processed by Symphonica. Unique IDs, customer associations, and states are all key pieces of information quickly and easily displayed in the order manager. And the last Symphonica domain to review before getting into an order execution is the party domain. The party domain provides the ability to search by customer ID to review the services and resources currently associated with that particular customer. This gives insights into the service and resource inventory as it relates to that specific customer. Now that the context of the Symphonica domains has been introduced, let's cover the basics of a service orchestration execution. A high-level overview of a service orchestration execution in Symphonica is as follows. Symphonica receives a service order request. In a typical implementation, this service order request will come in the form of a TM Forum 641 formatted API request, usually from the billing system. It is worth noting, however, that service order requests can also be created directly in the Symphonica user interface. Sympfonica's Service Order Manager will create a database entry and assign a unique transaction ID for each submitted request. This provides operators with the ability to view and review the details associated with all service requests sent to Symphonica. The Service Order Manager will then process each service order item and match it with the proper workflow based on the modeling and configuration of the service and resource specifications previously covered in this video. Symphonica will execute the associated workflow for each service order item and log and record the results. Symphonica then creates or updates the service and resource inventory for the customer as designated in the related party information of the service order request. Let's see this execution in action with a simple service request. We will start by verifying the current status in Symphonica. We can start in the service domain and see that we have a service specification for the remote provisioning of an eSIM. In the resource domain, we can see that we have a specification of an NMS with the code and name of RPS. And then in our resource inventory, we see that we have an RPS that is lifecycle status of operating and an overall status of up. We can use the party domain to determine the status of the inventory related to the designated customer. In this case, we use customer 101. Note that this customer does not currently have any associated services. And then finally, in the order manager, we can get familiar with the latest service orders so that we'll recognize when a new service order has been received. The execution of the service order will start with the API request to Symphonica. In this case, I will use Postman to emulate a billing system and to submit the request. Now that I have submitted the request, we can return to the order manager and see the service order in the system. Notice in this example that the state is complete, as the order was processed too quickly for us to catch it in an in-progress state. Other orders, such as ones that contain manual user tasks, will often show in other states. Selecting the service order takes us to the details where we can verify the order items and the related party information included in the API request. We see the customer ID in the summary and also in the related party information. In the order items information, we see a single order for a new embedded subscriber identity module. When selecting the order item, we can see more detail, including the service characteristics provided by the API request. From this screen, the service order item information also allows us to view the workflow process for that item. In this case, we can see the graphical representation of a simple workflow with 4 steps. Notice that in the second step, we can view the log information related to the execution of that step. Starting with the order data, we can see the status, the order spec code, and the resource name. We also have the opportunity to look at the input, output, and execution logs. Returning to the party domain, we can search for the customer. and see the database information recorded for that customer. In the inventory, we see the embedded subscriber identity module as a CFS. And under service orders, we see the service order that we generated with the API request. While this example is a simple workflow, it provides a good insight into the operation and the power of Symphonica as an orchestration platform. Housed in a single platform, Symphonica provides the service and resource modeling, the workflow construction, the service order management, the network provisioning, the service and resource inventory, and the execution logs, all in a no-code, intuitive user interface.